Coming up on This Week in Space, we've got moon landings galore, SpaceX's Starship explodes, and former NASA chief scientist Jim Green is here to tell us all about alien megastructures, Mars sample return, and so much more. So stay tuned.
Podcasts you love.
From people you trust.
This is Twit.
This is This Week in Space, episode number 151, recorded on March 7th, 2025, in search of alien megastructures. Hello and welcome to another episode of This Week in Space, the Alien Megastructures edition. I'm Rod Pyle, Editor-in-Chief of Ad Astra Magazine. I'm joined by my extraterrestrial partner, Tariq Malik, Editor-in-Chief at Space.com.
Hello, Rod. Hello, how are you doing today?
Well, I'm doing fine. How are you?
It's exhausting. It's been a crazy week in space, my friend. Crazy.
Yeah, it has. Normally, this would be where I'd say, oh, don't whine to me. But I was thinking while I was watching these stories cascade this week, and we were debating whether we were doing press releases about them. And it's getting to the point where, Starship is still news to us. But when it comes to the press cycle, it's like it blew up. It's kind of done. So, yeah.
Well, you say that. I
felt for you.
It's nice for you to say that. I was the one working till 11 o'clock last night, getting the photos of everything
hold on,
in space.
Hold on. Wait a minute.
Oh, yeah.
Oh, I got a tear. Look
for
at
everyone's knowledge, 15 minutes before we started recording this, I had to file an emergency story about one of the moon landings we're going to talk about today. So
let me see if I get a tear out of the other eye. Okay, good.
Not all of us get to run a quarterly that publishes once every 4 months.
A high-quality quarterly that has just doubled its distribution, I might add. But
congratulations.
Thank you.
Congratulations, Rob.
But I digress. The important thing here today, as opposed to you and me, is the fact that we will soon have Dr. Jim Green, who among many other titles was a former chief scientist at NASA, and I'll let him run down his long resume, but really brilliant guy. Great public engagement speaker, and of course, chief scientist for NASA. I mean, it doesn't get much better than that. And he's going to discuss a lot of things, among them Mars sample return and how to best hunt for extraterrestrial civilizations.
And the moon landing. Stick around for that.
We talked about technosignatures and all those moon landings. So stick around, because it's going to be a good one. Before we start, the trademark reminder. Please don't forget, do us a solid. Make sure to like, subscribe, and all the other cool podcast things, because we need your love. Now, drum roll, from my own archive of space dad jokes.
I'm ready.
Hey, Tariq.
Yes, Rod.
Why did the moon run out on its bar tab?
I don't know why. Because it's a cheapo?
No, because it was down to its last quarter.
I love it.
Oh, we're getting live effects from the back room here. Good. Now, I've heard that some people want to send us to another star system when we do our jokes on this show, but you can help. Send us your best, worst, or most indifferent space joke to twists@twit.tv. And now, headlines. So I think we have to, we're missing a sound effect this week, everybody. So bear with us.
Headline news. There we go.
Headline news. So I think we need to talk about moon landings.
Yes, we do.
This has been all moon landings all week.
I'm so tired, Rod. I'm so tired.
Just tell us.
Well, okay, yeah. So we started strong because as we're recording, this week started with the Firefly Aerospace Blue Ghost moon landing, which is like a midnight moon landing. Actually, I think it's the second link I have on here on line 22, John. But it seemed like if you want to talk about like a flawless landing. Having this first attempt by Firefly Aerospace, it was absolutely spectacular. In fact, the link that we have here is a video of the descent down to the plains of Mare Chrisium. So it's kind of like a
Mare.
Oh my gosh! When
the moon hits her eye like a big piece of pie, it's a mare.
And so they touched down. It was very, very smooth. They seemed to have a textbook touchdown. They had images very soon, about a couple hours after the landing, and they've got this great video that we're seeing if you're watching the stream now as it descends slowly, and then it captured this haunting picture of its silhouette or shadow on the surface with the moon or the Earth up above. And so far, it seems like that mission, it's a 14-day mission, the lunar day. It's been going pretty well. They've tested this vacuum sucking thing to collect regolith, which is part of a NASA experiment. I think it has 10 different NASA experiments as part of the CLIPS program, and it seems to be working great. And I think that they're really primed for using this template for all of their future missions to the moon too. So just absolutely spectacular to knock it out of the park like that, and the views are spectacular. Not so much for Intuitive Machines. That's the second spacecraft that landed on the moon this week. In fact, as we're recording it, the landing was yesterday. It was one day earlier on March 6th. And they landed their Athena moon lander. This is line 22 or 21, John. They landed their Athena lander near the South Pole of the moon. And this was actually a really audacious mission. And if folks don't recall, last year in 2024, Intuitive Machines landed their IM-1 Odysseus moon lander, but it landed too fast, broke a leg on the way down, and tipped over on its side. This time they had new cameras, new navigation systems, all sorts of stuff on it. Plus, they had NASA's Ice Drilling Prime 1 drill. They had two small rovers. They had a hopping spacecraft called Grace. Lots of different things, plus a Nokia Labs cell tower, a bunch of other stuff. Very audacious, going to the moon's South Pole, digging for that water ice. The approach seemed pretty good, but they had what they think a lot of noise in their navigation radar system, and they did hit the ground and tip over. They don't know if it tripped over. We don't know that yet, but they've got photos of it kind of sticking legs up, almost like a cartoon character, with the moon or the Earth, half-lit Earth above. And sadly, they're in a crater, which, we know it's really harsh at the South Pole of the moon. The lighting angles are very, very unforgiving. So they're not getting the power they need. The batteries have run out. They're not getting the charging that they need to keep the spacecraft alive for the lunar day that they were hoping to get. So it seems like that mission is over. Not the end of Intuitive Machines. They've got plans for IM-3 next year. IM-4 is in the contract, a $117 million contract with NASA in 2027. So they're going to learn from this. They said that they're committed to getting it, and they're going to stick it hopefully on the next attempt.
It would be interesting to have them on sometime, because I would love to find out, because I've been talking to a number of engineers about this and scientists, including our friend Pascal. It's the center of gravity is high on that lander. It looks like R2-D2 with
It looks
6
like
legs.
It's high, but they said actually that it's lower on this lander than it was on the first one. In fact, it was Tim Crane, their chief technology officer, said during the post-landing press conference that the center of gravity is lower than it looks like, and it's actually harder for them to control because of that, but they tried to make it as low as they could to keep it from tipping over, and it seems like just the rugged nature of the South Pole of the moon worked against them this time.
Well, and I also suspect they're stuck with the basic bus they have. They can't do a whole lot of adaptation quickly. But if you look at the Blue Ghost lander, it's very squat. It has a very wide stance. And I mean, we learned in the 60s with Surveyor, with that series of landings on the moon, that you wanted really wide legs and a very low machine. But hopefully they'll get it right next time.
Yeah.
Tell us about Starship. We're kind of tired of seeing these things streaming through the sky in pieces.
Well, I heard that Starships were made to fly, but sadly, SpaceX is having trouble with their new design. So they launched Starship Flight 8 yesterday. Was it? Yeah, it was yesterday. Oh my gosh, everything was this week. And if you might recall, this is the second Starship of the year. They managed the catch. They caught the booster for the third time. It was absolutely spectacular. They seem to have that process down. But they lost the ship again. About 20 seconds before the end of the ascent burn, they lost a bunch of engines. There's 6 different vacuum engines on the upper stage of Starship. And they started to lose a bunch about 20 seconds before they were supposed to stop burning. And then the ship just wildly careened out of control. We saw it tumbling in space. It did explode. It showered debris again over the Bahamas, Turks and Caicos, Dominican Republic. We got sightings from them all, including Space.com's own contributing freelancer, Stephanie Waldeck, who was on vacation in the Bahamas and just watched as the debris rained down over the beautiful, pristine waters there. So, I heard from the FAA today that they did have to close some airspace, delay some flights for a while until that debris dissipated, and an investigation is underway. But it must be frustrating because this is supposed to be like the new and improved, larger version of Starship. It's 52 meters tall. It has 25% more propellant on it, and this is supposed to be the next evolution. And they seem to be having problems just after separation, because this is a very similar thing happened on the January flight too. So we're going to wait and see how they evolve. And it's only been like 2 months between these flights. Will it take that long? Will they be able to iterate quicker for the next one? It's unclear right now. But I mean, the booster catch, they seem to have that down now. So we'll have to see how that develops over time.
Well, just so it's said, I mean, what they're trying to do is insanely hard. It's revolutionary. We haven't seen a development pace like this since the Apollo program, and in more conventional approaches from aerospace, these kinds of failures would engender a 3-year stand down, and here we're
or a cancellation outright.
Yeah. And they're doing it on a fraction of the money. So this is all terribly impressive. But I want to move on. The Voyagers. This is an unkind way of saying it, but the Voyager probes got their wings clipped again. They're very far from Earth. Their nuclear power batteries, if you want to call them that, RTGs, are getting old. They're approaching half-life, I think. And, they don't have much electricity left to work with, so they're starting to shut down more instruments. So each one got, I think, one more instrument shut down.
Yeah, that's right. In fact, it was kind of a twofer of shutdowns for the Voyager spacecraft. Voyager 1 and Voyager 2 each had an instrument shut down, because if they didn't, and this was really surprising to me, but Suzanne Dodd, NASA's Voyager project manager, said that if they didn't turn these instruments off, they would only have enough power for like a few more months on either of these spacecraft and have to declare an end of the mission. Yeah, it would be really sad. Voyager 1 and Voyager 2 are pretty much twins. They each have about 10 different experiments on them to study the solar system environment, the planetary flybys that they did. Of course, Voyager 2 did that grand tour that I have all these great posters around. Maybe one day I'll put them back up again. But I got them all from JPL for its tour of the solar system. But both of them are in interstellar space. Voyager 1 crossed out there in 2012, Voyager 2 in 2018. And like you said, the battery life isn't infinite. So they turned off Voyager 2's plasma science instrument back in October. And I believe the cosmic ray system on Voyager 1 was the most recent. It was a kind of a connection of 3 different telescopes to study cosmic rays, of which I'm sure there's a lot out there in interstellar space.
Nothing but. That's the whole definition of crossing the heliopause.
Yeah. But that system is the one that helped scientists prove that Voyager 1 indeed had left the heliosphere and was out there in interstellar space back in 2012. So it is kind of sad to see that one turned off, but they are going to turn off another instrument on Voyager 2. This is the second one, the energy charged particle instrument there. And that's what tracks cosmic rays, electrons, other ions across the solar system and galaxy. And they're going to, it's got 2 different systems, but it'll help them save a bunch of power to keep the other systems going on both of these spacecraft.
All right. And finally, secretive U.S. Space Force X-37B spaceplane breaks new ground.
That's right. So
did it break? And hopefully nose first.
No. So we had a question from a reader last episode. Your last listener. Readers on the brain. We had a question from a listener last episode about X-37B and what was it doing. And it turned out to be a very well-timed question because literally today, just before we started recording this, the Space Force sent out a blast to announce that the X-37B finally returned to Earth after 434 days plus in space. It's back on the ground, and it seems to be doing okay. It landed autonomously under the cover of night in the wee hours of the morning at Vandenberg Space Force Base, and this was a big mission for the Space Force because they tested a new orbit. They launched it on a Falcon Heavy instead of a Falcon 9 or previously to that, Atlas V. So they were able to go into a highly elliptical orbit. In fact, they released a photo of the full Earth from that kind of the high point of their orbit, and they tested aerobraking with this kind of winged design. It has heat shield tiles just like the space shuttle to slow it over time, which allows them to do orbital adjustments and navigation at a much more, I guess, economical rate when you take into account propellant and stuff. So they could change their orbit or adjust it and make refinements. So they clearly seem to have gotten a lot out of this mission. They're still not saying what they were looking at or what other stuff they were doing, right? But very interesting that they were able to prove this out. It'll be interesting to see if the next one launches on a Falcon Heavy. They have 2 of these X-37Bs, and they alternate them for missions. This is the 7th mission over time, not the longest. In fact, it's only longer than one other mission, the very first one, which was over 200 days. All of the other ones have been longer than this flight. So this is kind of short compared to the other ones. I think the longest was 908 days. That was the OTV-6 mission from the most immediate one prior to this one.
All right. And my last item is the recently released list from Skyscanner via Planet Cruise, which I got a release on yesterday, of the top 10 locations for dark skies to do stargazing and such.
Ooh, where should we go?
From 10 to 1, only one's in the U.S., sadly. Kittilä, Finland. Next one is Heihuan Mountain in Taiwan. Next one is the Gantrish Dark Sky Zone in Switzerland, which I've never even heard of. Next one is Lapland, Finland. We all know about Lapland. That's where Santa Claus lives. Next one
and the auroras.
Yeah. Oh, yeah. Sorry. The auroras were a big part of it, too. Yeah. Leknes, Norway. Salar de Uyuni, Bolivia. Mauna Kea, Hawaii. Yay, United States.
Yay, USA.
Waterton Glacier International Peace Park in Canada. And Reykjavik, Iceland. And finally, it's spot number 1, Interlaken, Switzerland.
Wow.
And that's your list. So if you don't live close to any of those places, you're out of luck.
What's the criteria there? Like, is it that Interlaken in Switzerland is the darkest sky you'll get on the planet, or
I guess, which
like
is
there's other things
puzzling because you'd be fairly certain that being out in the middle of the Transvaal in Africa would probably be the right place to be for the dark, or offshore a couple hundred miles. But I'll take my boat out and let you know. All right, everybody, hold on to your ejection seats because we're going to be back in just a moment with Jim Green, former NASA chief scientist. Go nowhere. And welcome back. We are here today with one of my favorite guests, Dr. James Green, former chief scientist for NASA, among many other appellations. Jim, I think you got your PhD. We were doing the math on this the other day. You got your PhD when you were about 12. Is that right?
Not exactly, but in 1979, I spent 1 year postdoc at Iowa, and by 1980, I was at Marshall Space Flight Center.
Wow. So my first question, and then Tariq has he has a trademark question he always asks, but my first question, I guess, I'd like to know what a chief scientist does at NASA, because that's a pretty all-encompassing term.
Sure.
And then if you would just kind of walk us through your career, because you had a lot of really impressive positions over the years.
Well, bottom line on the chief scientist is it's really pretty simple. The chief scientist has a direct report that is the administrator. And so he or she has zero money. So the chief scientist has no stake in any one particular activity. Unlike the division directors, which I was a planetary science division director, it's planetary first above everything. There's that nice tension going on. Chief scientist is really looking out for the health of the entire agency and all the science activity that's going on, and advises the administrator on any science question from an independent perspective and point of view. And this can range from, hey, please review this press release and tell me what you think of it, to taking me along and talking to congressional staffers about new elements in the program and what will be funded next year that they are interested in, and how would we do that. Another role the chief scientist has is really looking after the health of the scientist in the agency. This to me was one of my best funnest things to do. We have scientists in so many aspects of the centers that are doing all kinds of stuff, from building instruments to managing vacuum chambers and testing out instruments and spacecraft, writing scientific papers and managing data. The whole entire data stream, we have scientists involved in it. And so, how are they doing? What are the problems they're running into? What can the agency do to help them do their job? And that makes a much more attractive area for other scientists to come into. They want to work for NASA, not just because of the name, but because of the environment. So there are things that happen at centers with scientists that are there that need the attention of the administrator. And once I know what they are, I can walk right into that office and sit down and talk to the administrator and say, we have this problem. Here's how I think we should solve it, and get the approval to go do something about it. So that to me was a very, very important part of my job.
It's a lot of hats. That is
a lot of hats.
Yeah, it's a lot different than like being. I thought you were like Mr. Spock to like the administrator is Captain Kirk at NASA, but it sounds like it's a lot more than saying fascinating and raising an eyebrow every now and then. So
true. Although I have played that role before with Jim Bridenstine, who I work directly with, yes, that does happen. Also, when the administrator is so busy, they can't pull off all the events that are happening. Jim would call me up and say, Jim, can you go to this meeting? Or I need you to go to Europe and work on this. And you represent me in this bilateral or this event. So those things are very important. And the key to that whole position is it's agency wide. Now, I love that because my background is magnetospheric physics, which means I never met a magnetic field I didn't like. Okay, and then I did a lot of work on aurora, a lot of work on Earth-related space plasma physics, space weather, sun interactions, solar physics, and then gradually moved into planetary science, working on Voyager data at Jupiter and looking at all the phenomena that happens in that fabulous system. And then as a planetary scientist, I had a huge desire to learn what other scientists in that area are doing. Planetary atmospheres, Pluto, wow, Kuiper Belt object. We're going to fly by it for the first time. What does that look like? A whole new era of challenging missions that we really pulled off, and I think a real golden era of planetary science exploration that happened over those 12 years I was a planetary division director. So as chief scientist, I needed to know about what's the science on space station. What's happening in other areas. I'm familiar with astrophysics and heliophysics and earth science too, but I need to know more about each of these areas. And so I really spent a lot of time studying about the science that the agency does because I have to represent that.
Yeah.
So I got really fascinated in so many aspects of it that right now I'm working with Oxford on an experiment that's up on the International Space Station now, and we're working on another piece of it that's going to go up in April. So, who would have thought that I would have something to do with an experiment on the International Space Station in my career? I never would have, but that's what it led me to.
I would have thought that. I also wanted to note that you, for a period, if I read your bio correctly, we're running the National Space Science Data Center, NSSDC.
I did.
Which was where those of us, involved in trying to convert space science to media was the place to go, the archive for incredible planetary images and surface data and all this stuff. Yeah. And my God, what a collection that was. When were you there?
So I was there from 1985 to 92, when I then had the opportunity to create an entire division within the Space Science Directorate at Goddard Space Flight Center, and I included the National Space Science Data Center as one of the three branches. So the NSSDC was part of my portfolio from 85 to about 2004, when Ed Weiler, the center director at Goddard Space Flight Center, called me up in a panic and said, "I need to have you create a new organization." And what was happening at that time was we were moving into an era that's called full cost accounting. This was something new for the civil servants. The civil servants had to be able to propose and win money to pay their salary. Okay. Oh. And the reason why he called me up is I happened to be one of the most successful proposers. Now, as a civil servant, I didn't need to propose, but I had so many friends, when I graduated at the University of Iowa, and many of the science friends that I met at Marshall Space Flight Center and Goddard Space Flight Center that were on what we call soft money. That means they have to completely have their salary made up of winning proposals. And I was involved in those proposals, and I wrote proposals, and sometimes I was a PI, and sometimes I was a COI. Now, as a civil servant during that time period, I didn't need to create money for my salary, okay? I was doing that because I was interested in the science, and it went to help support them if we won. That money went to them, didn't go to me. So that worked out great, and I got to learn how to write proposals. And there were several others at Goddard, but indeed, Ed said, your record is great. I was winning. I wrote, I wrote 52 or 3 proposals, and won about 25 of them. So I was running 50-50. Whereas it's really good if you get 1 in 3. And it's sometimes that, right, when the money's really tight, it's 1 in 6. Well, that's terrible, So I helped pull an organization together that then began to train the Goddard scientists on how to write a proposal that's successful. And that group is still there at Goddard. I was doing that when I was asked to go down to NASA headquarters and be acting as head of planetary science. So that was 2006. And I liked the job so much that when the opportunity came up to apply for it, I applied for it, and I got it.
Wow, you almost make it sound like fun. All right, we're going to go to a quick ad break. We'll be right back with Tariq's trademark question in just a moment. Tariq, you're up.
Great. Well,
His favorite thing to do.
I feel like you really are overselling the question from this one. But
it better be good. I bet be really probing.
I am always interested in the space origins of the people that come on the show, Jim. Like, what is the key driver? Like, for me, it was my cousins watching a scary movie, so I ended up going to watch Star Trek in someone like my aunt's garage. That hooked me in space exploration or whatnot when I was a little kid. But I'm curious, like, where you fall in that. Like, was the space bug something that bit you when you were a little kid? Was it something that you found through your studies, or how did you kind of get the ball rolling to reach the heights that you did? That you have so far.
Well, I was immersed in space. You have to recognize that, I was born in 1951. And so in the 60s, we were going to the moon. All right. So that whole thrust, Sputnik was up there. Now, although as a young kid, I was 8 years old or 7 or 8 years old at the time, I never saw Sputnik, but the parents were talking about it and the neighbors were talking about it, and wow, it's space, and I watched the original Star Trek from episode 1 on. Okay. Wow. Wow. And so by the time I got into high school, I took chemistry as a I guess I was a sophomore at the time, and the teacher who was teaching chemistry ended up with the keys to the observatory that the high school had. And that observatory was a 12-inch Alvin Clark refractor. This is a wonderful telescope. I mean, the tube is 15 feet long, okay? 12-inch lens, okay? It's a refractor. And he wanted, students to get involved in it. So I got very involved in that astronomy. Wow. I did all kinds of astrophotography. I built instruments in the back of it. I learned how to print things in the old way. I mean, there wasn't GIFs or JPEGs, digital data. You had an analog negative you had to make.
This is high school. I mean, I want to point that out.
This is high school.
My high school didn't have an observatory. Where was I?
Yeah. So I was down at the school all the time. Okay. So don't tell anybody. But he even gave me the keys to the high school. Because the telescope was on the roof. So at night, 2 a.m, I'd be down there observing, some phenomena, and taking pictures and the next day come in and make the negatives and then start making prints. And then I sent them in the Sky and Telescope. I have things that I took with that telescope in Sky and Telescope.
I was going to say, so when you're in high school, you're sending photos into Sky.
Yeah. Now, that was no big deal. I mean, because that's when Sky and Telescope was totally an amateur magazine. Everything in it, was planetary astronomy. Because what was happening, there was no such field as planetary science. It was planetary astronomy. Everything that you knew about a planet, you got from the back end of a telescope, period. Okay. And so that, I was immersed in that. So I had Sky and Telescope subscription. And then in '69, when I graduated, we landed on the moon. I went to the University of Iowa and I took Astronomy 101 from James Van Allen. All right. Wow. Yeah, I walk into his first lecture with 450 students. I mean, the place was packed. Okay. And so I did good that semester. And second semester I took not only Astronomy 2, I also took a course called Readings in Astronomy, taught by staff. Okay. Now, Van Allen didn't teach the second semester astronomy course. I was taught by someone else. And I took this Readings in Astronomy because I had just a 2-credit hour available in my course curriculum. And, it said, go to room 704 in Van Allen Hall. So I go up to 704, walk in. It's a corner room, open the door. And it's a huge room, and it's got tape racks, and it's got printouts, and I'm standing in the hallway with this bookcase right next to me, and I'm going through the course catalog. Did I get the right room? And Van Allen leans from behind the bookcase and says, "Yes, Jim, you got the right room, and you're my only student."
Oh, wow.
Whoa.
Yeah, whoa. I'm a freshman.
That's a little more attention than most of us wanted in our freshman year.
Yeah. Well, now I knew of Van Allen before I went to Iowa. I have to tell you, because in high school, I was a senior. I took physics, and one of the great things that they made you do is every week you had to read a Scientific American article and write a 2-page summary of it and turn it in. I loved that. I really loved that. I thought, God, this is so great. One day in my career, I'm going to write an article for Scientific American. That was, so that was my high school objective.
Wow.
And then of course, Van Allen wrote a wonderful article about Van Allen radiation belts in the magnetosphere that was in Scientific American that I reported on. So I was really into what he was doing. And so he learned what I did by using this telescope. And one of the things I did is I took a picture of the sun every day for 6 months straight. Didn't miss a day. Okay? Now, sometimes I would set up the telescope and it had a filter on it, so the sun's light would shine through, but only, in a degraded way, such that you still got an image, a really great, beautiful image, but you didn't get all the light from the sun. Mm-hmm. And it was actually a Questar filter. Questar was making telescopes with filters at the time. We just got the filter, and then we made a mast for it and put it on the telescope. So we're constantly making stuff, okay? And then this, I would wait sometimes hours for the sun to just peek out between the clouds to take a picture. So I made 35 millimeter color slides out of this whole set. And I told Van this, and Van says, "Oh, you got to bring it. Let's see that." So I went home that weekend, and my next class with him, I said, "This is what I got." He goes, "Wow, let's do some research on this. You've got all kinds of data." And I said, "Research? What's that?" Okay. And so we figured out what we could do, since it was sunspot maximum, was sunspot rotation. Okay.
Yeah.
And so I had many months where I had three or four sunspots that rotated 3 times. I had, a dozen or 2 dozen sunspots that went around twice, and then 50 or more that you watched going across the disk. And so I wrote a paper. I had the title, an abstract, an intro. He was telling me how to be a research scientist. So at the, I got it all together with my references and my figures. I did data analysis, error analysis I did, and he was the referee on the paper.
Wow.
You and
I had very different astronomy introductions. I overwrote an entire week's worth of solar data and was put on the kiddie computer that wasn't connected to anything. So I'm in awe, Jim.
Well, and I think he also passed calculus.
I was going to say differential equations too, Rod. I'm pretty sure he passed that class.
Well, I was good in math. And I was good in science. But I have to tell you, not all math is created equal. I hated geometry.
Well, we have something in common. All right, we're going to go to one more ad break, and then I'm going to come back with my fun question. So stand by. So, Jim, we have a lot of science to talk about, but I have to bring up something. So I think the second encounter I had with you was in 2015-ish. I was working at Caltech. I was writing there. And we got this big, long memo, I think it was 9 pages or something, from NASA headquarters about how we should discuss The Martian, the movie The Martian. And you were the scientific consultant on that. And I think I wrote you an email saying, can you tell me more about this inciting incident of this non-existent 200-mile-an-hour wind that would be kind of a breath to a feather on Mars, threatening to blow over the spacecraft, and they took off? And you said something to the effect of, well, they didn't listen to everything I said.
Yeah, that was really another accident in my life, so to speak. If you think my early career was made up of one accidental occurrence after another, I was head of planetary, and in that group had 3 branches. One of the branch was the Mars Exploration Branch. Okay, this was run by Doug McQuistion. And that branch, that person that leads that branch is commonly called the Mars Czar. Now, why we call that person the Mars Czar is that he or she, in this case it was Doug, and Doug oversaw every asset at Mars. In terms of how they're coordinating, what they're doing, how we have to move satellites to get imaging in certain areas, how we have to support landings or getting other spacecraft into orbit, how we do relays, everything. So that's why that one person is called the Mars Czar. Prior to Doug, it was Orlando Figueroa, and prior to Orlando, it was Scott Hubbard. But what happened after we landed Curiosity, and Andy Weir was developing the novel, etc., Doug retired. And so I was now acting Mars Czar. So I was doing all the Mars stuff, and I was doing all the other planetary stuff, and so I was working like 16 hours a day. It was terrible. I hadn't worked so hard, to keep everything going while I'm trying to hire somebody to be the Mars Czar. In the meantime, Ridley Scott calls up NASA headquarters and says, I want to talk to somebody that knows something about Mars. So they must have gone down the phone book and they said, okay, here's the Mars exploration branch, Jim Green acting. Here, call him. So Ridley Scott, calls me and hadn't read the book. And the call was arranged by Bert Ulrich. Everything goes through Bert at that time for media, whether it's music or film or documentaries.
Right.
And so Bert set it up, which was wonderful. And I had a wonderful conversation. By the time I got done with the conversation of talking to Ridley and about 5 or 6 of these other people about Mars, I mean, all we did was talk Mars facts, talk about propulsion, everything from ion engines to spacesuits to, walking on Mars. You name it, they were all over the place. And there were a couple things I couldn't answer. And I said, I don't want to mislead you. I don't know the exact answer to that, but I know who does. Okay. So we'll make those connections. And so before the conference was over, he'd already emailed me the script. Okay. So this was like Wednesday or Thursday. Okay. And on Monday, there was a big meeting in the communication group where they were going to talk about what they were going to do relative to this movie. So I thought, okay, I better read the book. So I got an ebook. So that weekend, I read the script and read the ebook. Monday, I walk in and sit down to the big meeting where we're going to talk about what NASA should do relative to the Martian. So NASA gets, a couple hundred requests for support on all kinds of things, from documentaries to movies. And so they have to be picky. They can only do so much. And so they're running around the room. What about this documentary? What about this? And then they came to me and they said, Jim Green, what do you think we should do about the Martian? And I said, we need to be all in, whatever Ridley wants. We need to make sure he gets it. This is fantastic. Ridley wants to make it as realistic as possible. We can't have a better opportunity to tell the public the look and feel of the red planet. And it all went like this. And then David Weaver, the head of communications, says, great, we'll do that, and you're going to lead it. And I'm, oh, Jesus, oh, God. I'm already working
17 hours a day. Yeah.
It's 18, 19.
We should remind people, for like the 3 people who are listening who don't know what The Martian actually is. It's a film starring Matt Damon as a stranded astronaut, a real one. Rod, a real stranded astronaut on Mars.
This is really stranded. This is what we mean by stranded. Yeah, that's right.
Based on a book by Andy Rear.
And interestingly, that book was originally just fan fiction published online.
Yeah,
and it just took off like crazy.
Self-published.
Jim, I have to tell you, I think you might remember this because we're of a similar age. I left The Martian and I was kind of satisfied, but I felt after I'd seen the movie, I thought, I've seen this before. And I went home and loaded up my Laserdisc of Robinson Crusoe on Mars and reminded myself that the first 2/3 of that movie was great. And then when the creepy aliens show up and it got kind of weird, but there was a similarity there. Okay. Sorry, Tariq. I know it's your turn.
No, I was going to say though, and Jim, I think that the enthusiasm was not just warranted, but it really comes clear because if our audience doesn't recall, The Martian came out as kind of like the 3rd film in a trifecta of like real space-based films. You had Gravity, which was Sandra Bullock stuck on the space station after it gets destroyed by space debris. You have Interstellar, about a dying Earth and we have to find another planet. And in both of those films, Gravity, we've talked about this before, Rod and I, Gravity and Interstellar, they don't want to be in space. No one wants to be in space. In fact, Sandra Bullock says that she hates space, but in The Martian, that spirit that I have seen, and I'm sure you have too, right, Jim, from the astronauts and the scientists you talk about they would still be there. That he loves being on Mars, even though he's stuck there. It was the first one where the joy, I think, that I see from folks like yourself who do the science, from the astronauts, really came through, and I think that needs to be celebrated just a little bit more, especially these days.
Well, I got a couple things to tell you about that, because my absolute favorite scene in the movie is when he's sitting on the rock and he's composing in his mind the letter he's writing to Commander Lewis. And I went back to the script because I didn't remember everything that he said was in the script, and it wasn't. He whether it was Ridley or he just let Matt riff a little, actually added some really nice parts to that. And so that when he sits there and talks that way, it almost a tear comes to my eye, that's the drive he had. He said he may die on Mars, and I am okay with that because of what it means to explore in this manner, and why we need to be on Mars to continue to do so. So it was a wonderful experience, and I had a wonderful time doing it, and it about killed me, but that's the way that went. That's okay. I went to the premiere. They invited me to go to the premiere.
Oh, that's
so Ridley calls up NASA headquarters and says, "I want Jim to come to the premiere. I'm going to send a plane for him." And NASA headquarters went berserk. "You're not going to send a private plane for him. He's going to sit in economy on some jet." And then Ridley said, "Well, we've got this hotel in Toronto. It's the Toronto Film Festival. So the Cannes of the Americas is the Toronto Film Festival. Okay, that's when it's all shown." And he says, "We're in this hotel. I'll put him up in this hotel." That's way over per diem. He can't possibly be in that hotel. So they put me in this hotel, miles away, because everybody's there, at the premiere. So the premiere was great. I had to walk the red carpet. That was shocking. I wasn't even wearing my best suit. They don't tell me these things, right? And then we spent the rest of the next day, talking to reporters, and I was on panels with Ridley and panels with Andy Weir. Talked to Matt in the hallway, and just had a great time.
All right, we're going to go to one more ad break, last one, and then we'll be right back with Tariq's next big question. Stand by.
Well, one of the reasons. Sorry, I'm late. We were having some discussions offline, everybody. So I'm dying over here. But one of the reasons, Jim, that Rod and I hope to get you on here was to get your thoughts about things like alien megastructures and what they mean about advanced ET civilizations that are out there. Because I heard that you have thoughts, and you were just hinting about it for Interstellar. So I think for the people who are listening, I first even knew that alien megastructures and what is it called? Technosignatures could be a thing when people were talking about Voyager's star way back when. I didn't know that it was even a concept back then. But tell me your thoughts, Jim, because obviously NASA gets asked about this stuff all the time, and I'm sure that you've got a gripping answer that will solve everyone's questions, right?
Well, let me give you a little backstory, if I may. SETI came along, and NASA was involved in developing radio receivers and doing a number of things that would look for the search for extraterrestrial intelligence through coded radio signals that might be captured in our new radio dishes. The key to that is to have them on, look out, and gather that data and see if we can find a civilization that's doing that. Because we do that, when we created TV and radio, and all those radio waves leave Earth. So we're just leaking radio waves like crazy. So it's a good idea. And started in the 90s, and NASA started working in that direction, and then got congressional direction to get out of it. All right. And that meant that SETI, Search for Extraterrestrial Intelligence, was going to be done via radio signals by the private sector with private funding. So NASA, particularly in planetary science, we're going after biosignatures. Let's look for real life beyond the surface. We invented planetary science because instead of a back of the telescope, we're on the surface. We're measuring the atmosphere. We're, looking around. We're digging in the dirt. We're doing that science right there. And so we have an opportunity to, create concepts on what life might leave if it was there and died, or what signatures might tell us life is there but under the surface. So all that was coming to play. But what was happening is there was a big push in Congress, particularly by Lamar Smith, to help fund SETI, to really get NASA more involved, bring NASA back into the search for extraterrestrial intelligence. And so I was chief scientist at the time when Jim Bridenstine called me and said, "Come down to my office. I'm talking to Lamar Smith and his staffers." And we started talking about the money they want to give NASA to look for intelligence, extraterrestrial intelligence. And I suggested we do a workshop. We bring in the community. We talk about all the other things that could be seen now that we're really looking for, looking at exoplanets and finding them all over the place. What are those technologies that could be developed by another civilization and we actually could observe, and maybe we have in our data, if we allow an opportunity for our scientists to think about how to dig that out of the data? And that would be technosignatures. And so we had a wonderful workshop. A report came out, and indeed NASA got $10 million, started that, and we are still doing research in technosignatures. Now, it's not just radio. It's looking for structures, megastructures. What are the options in megastructures? Well, Freeman Dyson in the 60s wrote a wonderful paper about, really advanced technologies and civilizations are going to want to capture all the energy from its dying sun. And so that would be called a Dyson sphere, something that would surround a sun.
I saw that in Star Trek, right? They found Scotty crashed on one of those. So.
But there's other things. O'Neill had an idea also inspired by the Apollo program that what you want to do is you want to have huge space stations. And those space stations, you want to bring Earth to them. All right, so you want to grow food. You want to be able to have a living environment in space. You want to preserve the environment of the Earth by having it also work in space. The key to that, I mean, it's like if you saw the movie Elysium, that was an O'Neill structure that, once again, Matt Damon.
I'm going to say, we've mentioned Interstellar too. That's all three Matt Damon space films that came out in 3 years.
Yeah, true. But he was a baddie in Interstellar. But to me, Interstellar missed the boat by not going through an O'Neill structure concept. So we all know our star evolves. We all know what will happen to our star. Over time, it gets brighter, it burns up its fuel, and then it shrinks, and then it goes through a massive change by expanding its surface. While interior, it changes the way it creates its fuel. Instead of hydrogen coming together and creating helium, they now take helium and have it come together and create carbon. And so that puffs up the surface, and all the planets will, die. But we'll have all kinds of heat problems from the sun in another 800 million years. Okay. Well, 800 million years, we're going to get twice the amount of heat from the sun we get today. We'll get the same amount of heat Venus gets in 800 million years. Well, Venus, we know what that's like. That the surface is hot enough to melt lead. It's way too hot. And so if you want to preserve Earth and you want to be able to create a controlled environment, you want to create a structure that's more Earth-like. It has to be big. It's like biosphere in space. You want to be able to have a self-sustaining system. And all those are wonderful technologies. And so I think they have a place, a real place in our future. And that is, as we become technologically more capable to then develop large structures, we will save the best parts of Earth and put it there.
I like that.
That also
idea.
gives us the flexibility to move further away from the sun. So I think technosignatures could be observed. Really big O'Neill structures could be observed in the data that was taken by Kepler and TESS, and many scientists are looking for it now.
That's great. I would, by the way, just to remark on something Jim touched on, for any parents out there, avoid mentioning the death of the sun to like your really young children, because
they stay up all night.
When my daughter was 5, it was one of the most difficult existential concepts conversations I ever had. Was when we were reading one of those kids' books that tells you the life cycle of a star, and it tells her how the sun will go out, and then just an immediate realization that everything ends before you're ready to deal with it. So just an advice. But I did want to ask.
We'll probably get hit by a Neo well before then.
yeah. Oh my gosh, it was really difficult.
You didn't tell her that, did you?
No, but I have flashbacks when you're talking about the death of the sun, about that whole discussion. I wanted to ask about just the search for both the technosignals and technosignatures. Is there like a plan? Like, did you help create, or did they show you like the secret plan when you become chief scientist of what NASA's gonna do when they have something that's conclusive? Well, like Contact, right? We're talking about space movies and books, and Carl Sagan's Contact, with Jodie Foster in the film. They've got a whole reaction, about how humanity has to react to it. Is there a plan like that?
No, actually, Mary Wojtek, who is the head of the astrobiology group within planetary science, and now it's David Grinspoon working with Mary together on that activity. But when it was just her, she and I had quite a bit of discussions of, okay, we might have an opportunity in this generation to find signatures of life, okay, whether it's technosignatures or whether it's actually certain biosignatures on Mars that lead us to an understanding that it's life, okay. What are we going to do next? How are we going to relate to that? How, what's going to happen in terms of how we get the word out? Because we know how that's going to happen. NASA's going to, the freight train's going to move so fast, taking those results, getting them to a point where we can do press releases and press conferences and interviews on the Hill and interviews with, Space News. You'll be right up there, you guys. You'll be, instead of me, it'll be, Scientist X in the future. But
I call dibs on first question. So.
Yes, okay, you can. But that next big step, wow, it's a big one. And I don't think we've worked it out.
Mm-hmm.
Well, I want to have the alien himself or herself on the program.
Or them. We don't know. Why you got to have two genders, Rod?
One over my shoulder. Well, that's true. That's true.
Or any genders. We don't know.
Before we run out of time here, I would really like to hear your thoughts on Mars sample return and where we are with that and where we might go. Because I know that's something you thought about. I mean, you think about endless things, so I can't keep up. But that's one we've talked about a lot on the show. We had Rob Manning, the chief scientist over at JPL on.
Right.
He spoke about it. We've had others. But it's frustrating to watch from here.
It is. And in terms of, you want to talk about the next alien, it actually might be right here. Okay, this is...
He has the first sample from Mars.
Well, it's actually from Earth. It's a piece of granite, but it's from their engineering unit out at JPL. So this is the kind of samples we want, and it's got a history here. There's a stratigraphy of what happened and how that rock was built. Yeah, and then that is placed into a container like this. And then that container is either laid on the surface or will be handed over to a rover or an arm that will place them in a rocket and then return. Well, 10 years ago, when we were constructing the idea of, we know now with Percy we're going to get these samples. Now we got to figure out how to bring them back. We were really limited because what we had were rockets capable of only allowing us to land about a 1.5 metric ton, whatever, rover, whatever. Well, in this case, it would be a Mars ascent vehicle. But what's happened today is that even though that plan 10 years ago was okay then, today we have all kinds of new ideas that we need to bring in, all kinds of new capability, like the SLS, or even Starship in the future, any super heavy lift launch vehicle that can bring large masses to Mars. We have the opportunity to land. We could land a 20-ton MAV, which is a Mars ascent vehicle, and then bring all these samples to the MAV and take off and bring them right back to Earth, direct to Earth. That makes it much simpler. It uses the agency assets that we have today. There's so many positive things about it. Plus, that MAV could be evolvable to the point where we end up with a MAV for humans. Now, this relates to the Martian, and the reason why is Andy Weir didn't explain the most difficult thing. He already just assumed it was there, and that was the MAV. How did that MAV get there? Here it is. We're just going to go to Ares 4, and the MAV will be there. Well, that is one massive rocket. That's probably pushing 80 metric ton. But we've got to be able to do a variety of tests on the surface to get to the point to bringing the astronauts back, or we won't have humans on Mars anytime soon. And I think Mars sample return would be what I would suggest is our first big opportunity to develop the capability that could develop into humans returning from Earth, from Mars to Earth in a very large structure like that.
I'll do it. I'll go and I'll get those samples and bring them back. I promise, right? I'm sure I can do it. What do you think?
Now, do you know why we decided to lay them on the ground?
Well, I thought that's because, we have to take littering to the cosmic frontier, right? No? Is that?
No.
They're easier to pick up?
Well, here's the deal. When we were developing the concept for Percy, we were assuming, okay, we're going to take all these samples and we're going to stick them in a can, and then the can will reside on the rover, and then we'll have another rover coming up and then reach in there and get the can and take it to the MAV. Well, the problem with that is because of the rover and the difficulty in getting those samples off the rover, that obligates NASA to be able to do that. But if we create samples in a tube and lay them on the ground, any nation can bring them back.
There you go.
Oh, interesting.
Yes. And now that mission is sellable. Now I can convince OMB, the Office of Business and Management, Office of Management and Business, to provide support for that administration to propose to Congress for us to do Percy. All that worked because it didn't obligate NASA to do the next mission. Well, right now, the samples are there, and we're going to bring them back, and no other nation is there to pick them up. So, in a way, we are going to do that. But the bottom line to that is the idea was very flexible, and it could have been India, it could have been JAXA, it could have been many other different types of space. But Jim,
what if a supervillain builds his own private moon lander and goes and takes the samples for themselves? What do we do then?
Well, no. Okay, we will know about it. And 2, we will have international agreements to be able to share the knowledge. Yeah. Let me tell you something about these samples. Here on Earth, these are rocks. Rocks have, the mineralogy of how atoms are arranged in a lattice to create the rock. Okay, that's what we have here. And here on Earth, we have 5,700 minerals that we've identified. But 349 of those are only made with dead life. Mm-hmm. So getting a rock record back and interrogating the mineralogy over time is a big hint to us on whether life existed on the surface of that planet or not.
Okay. Oh, that's awesome. Well, I do have one more question, and I know that we're running a little short on time, so hopefully I could squeeze it in. But we talked a little bit about the news segment earlier, Rod and I, about some of the other planetary science stuff that was going on this week. We had 2 moon landings, in 1 week, which was exhausting. One really successful, and actually a few minutes before the start of the show, I published a story about how the Intuitive Machines lander had fallen over, sadly. So that mission is over. But I'm just wondering how, as someone with your science background, you're feeling about this kind of onslaught. It seems like year after year now we're having these moon landings or moon landings attempts. In fact, Japan, we're talking about international agreements, has its own lander Resilience on the way to the moon for a landing this summer. And I'm just curious: is this exciting? Is it the norm, or is space kind of hip and where it's at again? Like when you were a kid, seeing things launch all the time that you were talking about there.
Well, I have to tell you that as head of planetary, if I wanted a big rover or I wanted something new that wasn't in the program, I had to create the information and get it sold not only to the administrator of NASA, but the administration, the president, and Congress before I'd get the money to build something new. That's called a new start. Mm-hmm. And new starts I managed were Curiosity, Perseverance, including the helicopter, DART, Europa Clipper, and CLIPS. So you're asking the guy that helped put the whole future program together on the moon, the commercial lunar landing activity that is part of CLIPS. And why did I do that? Because indeed, that's the wave of the future. We want to be able to have more commercial activities. We want to be able to bring on some new companies, get them up to speed on doing these hard things, making them more routine. And as you can see, we've had some failures. NASA had 4, maybe even 5 missions to the moon. The first 4 or 5 were all failures. I mean, I think one of them was trying to hit the moon, and we missed it. Now we missed the moon, So how can we do that? But it's hard, And now we have companies that are coming on and are able to do that. Well, the moon is a resource for us in space. Now that we know so much more about the mineralogy of the moon, the kind of precious metals that are there, the amount of water and other volatiles that are there, that the moon is an enormously important resource. And I think by exploring that the way the government does through NASA and bringing along the commercial environment will speed up the process of allowing us to be able to live and work on the moon, learn how to do that on a planetary surface, and then take that knowledge and go to Mars. So it's I think one of the big first steps we have as a country and of course the world to look at how we should be living and working in space. Mm-hmm. Because I firmly believe we as a species are not going to survive very long if we give up going into space. We've got to utilize all activities in space, from communication to observations to resources. You name it. Our big future is space. And so let's get on it.
That's why we asked Dr. Green to write the capstone chapter for the National Space Society's upcoming book on advanced ideas in space settlement. Before we let you go, Jim, I wanted to ask you about 2 things. First, about your new education initiative that you're working on, which is very exciting. And second, if you wanted to mention the Mars book that you co-authored.
All right. Okay. Well, what I've been doing is teaching in the metaverse. Okay. I got this idea by going to several space agencies. As my role of chief scientist, I was there talking to them about various things like the Artemis Accords. When I graduated the University of Iowa and I started space, career in the 70s, when I was getting my degree, there were 4 big space agencies. Okay, Russia, ESA, NASA, and the Japanese. Those 4. There are now 70 space agencies. And if you go to those countries and talk to them, they want to have the space agency run, managed, and done by people living in their country. The problem is they don't even have aerospace classes in their universities. So you got to be able to inspire these kids. I mean, these kids walk around here's my cell phone, and I'm going to this place and that place, and I'm using Google Maps, not realizing that, that's facilitated by space. Just about everything they do in their life has a space component to it. Mm-hmm. Even Uber uses space to get you where you need to go and calculate everything from how long it's going to take to departure and arrival times. Bottom line is, this is so important to then inspire the youth that the only way to do it is in virtual reality. You got to go where they are, okay? And they play games. They put on their Oculus, which mine is over there. I won't reach and get it just to show you. But, it's a capability that I connected with several people that are gamesters, and they developed a spaceship that orbits the Earth. That's where I teach. We beam down to the moon. We walk around the Apollo sites, or we beam down to Mars, and we walk around the Curiosity sites on Mount Sharp. And then this is real data, that we've imported. It's three-dimensional around, and by teaching in the metaverse, it's really connects. I've had 20 or more teachers in 5 time zones teach students all over the world. Mm-hmm. And so we're still doing that. In fact, I'm teaching in another couple of weeks a series of classes on Saturday. So we're also trying to teach during the school year, but instead of during the summer, we teach on Saturdays. Now, with that said, I also enjoy outreach in terms of telling people what we're doing. And I had a wonderful opportunity several years ago when Tashin called NASA and said, I want somebody to help develop a book about Mars. And Bert Ulrich called me up once again and said, Jim, do you want to do it? And I said, you bet. And the end result is now out. It's this book.
Wow. Mars. Look at that thing. Where do they put? What shelf do they put that on? I guess that goes up top, right? Holy moly.
Yes. Well, if you know Tashin, they do a wonderful job in many different areas. Art and structures and architecture, and they're really into visuals and stories about those. And so Rob Manning and I also. Margaret Whitcamp from Air and Space Museum, Emily Lactawana, we all got involved in making this book happen. And it's a coffee table book. It's beautiful pictures, but it's got some great stories in it that we wrote. And so once again, it's one of those things that I wanted to do that reaches out to people, that gets them excited about what we see and what we've done in our solar system. Interestingly, when I was taking solar system physics in University of Iowa, I wrote a paper on Mars using Mariner 9 images. And that to me was just such a huge advance from what I was doing just 5 or 6 years earlier, when I was only looking at Mars through a telescope. And now we're really looking at Mars from our orbiters. Well, now we're looking at Mars by roving on it and really digging in the dirt. It's a wonderful set of vistas. The mountains are higher, the valleys are deeper, the volcanoes are unbelievably huge. Why? Because Mars has less gravity. And so they don't crunch down. And these vistas are just, wow, really inspiring. So I think I wanted to get that message out, and I hope more and more people really, take that in and enjoy it just like us scientists do.
Well, kudos to you, because getting deals for coffee table books these days is not a trivial thing. I did one in 2019, but I don't see many in my future. I want to thank everybody, especially you, Jim, for joining us today for episode number 151. We call Seeking Alien Megastructures. Where's the best place for us to keep up with your many new ventures online, Jim?
Good question. Well, I haunt Facebook. I haunt LinkedIn. I try to post some things that we're doing. And that's the best 2 you can do.
Excellent. Tariq, where can we find you being a game console astronaut these days?
I haven't had to play a video game in 2 weeks, Rod. It's been crazy in space.
For you.
You can find me at space.com. As always, this weekend, we just had the 2 moon landings. We had Starship explode, which we talked about. And this weekend, Sphere X is going to launch. So you'll find me watching that launch this weekend. Hopefully, it's been delayed for about a week plus, but we'll see how that goes on the Twitter, as always, at Tariq J. Malik. Also on Blue Sky and on YouTube, like Rod always likes to say, at Space Drawn Plays. It's a new event in Marvel Rivals. Free skins. A lot of great stuff.
In what Rivals?
Marvel Rivals. They're all astronauts in there, the Fantastic Four. That's how they got their powers. They went to space, my friend.
Actually,
they did, and they got hit by a solar storm.
That's right, cosmic radiation.
Which
they talk about it in the game.
Everybody into a weirdo. Okay, and you can of course find me at rodpylebooks.com or at astromagazine.com, where you can also get more information about the National Space Society, where I base my home groove. Remember, you can drop us a line at twis@twit.tv. That's TWIS@twit.tv. We welcome your comments, suggestions, and ideas. And don't be shy. New episodes published every Friday on your favorite podcatcher, so make sure to subscribe. Tell your friends. Give us reviews. We'll take 5 thumbs up or 5 alien heads, whatever you got. And don't forget, you can join Club Twit for just $7 a month. What a deal that is. Can either of you guys think of anything better you can get for $7 a month than access to all these shows without ads? I can't.
No, never.
No. And it helps keep the electrons flowing your way because we love you and we want to stay here. Finally, you can follow the Twit Tech Podcast Network at Twit on Twitter and on Facebook at twit.tv on Instagram. Gentlemen, this has been a real pleasure. Jim, we're going to have you back because we just don't have enough time to cover all this stuff you've done. You've done a lot.
I think we call you back later this year when Fantastic Four comes out, because it sounds like you've got thoughts on that movie. So.
Yeah, flame on.
All right. Well, and I hope it's better than that awful one. There was some B-level movie they did of Fantastic Four where they actually had baggy costumes on, which I thought, let's not go there. All right. Thanks, everybody. We will see you next time. Take care.
Thank you.